How are we all doing? Hope you're okay. Transition. I am here. Can I get some communication in the chat? Hopefully I didn't put it to that you have to be logged in. Let me just check and make sure the audio is okay. Okay. I can hear myself. Good sign. Awesome. How are we all doing? The Thursday. We're close to the Friday. But if you haven't read the stream title, we are going to be setting up a sinkhole application today. And if you don't know what a sinkhole application is, it's just a place where you could just waste attackers' time, send them to a place and just say, hey, you can keep sending me requests or anything like that. And it doesn't matter. It will just end up in the gutter. So, we're 3 minutes past now. So, we'll start. So, in front of me, this is just a Debian box that I've just spun up. So if I type uptime and enter, you see it's been running for 42 minutes. It's pure bare basic. I haven't done anything mainly to it except for I've already installed Nginx. So there's already a web server running on here. So if I call localhost, I get the Nginx default page. So the first thing that we need to do is install CrowdSec, because it has a new box. There's nothing installed, so we need to install that first. So if we head over to documentation, give me 1 second, guys. I'm gonna take out one earphone. So if we head to the documentation, you can see here that we've got the install CrowdSec 2 minutes. Also, if you do see flashing at the top, yeah, my bad. It's just when I use my Wayland manager like that, for some other reason it flips out and starts flashing. So within documentation, if you go to install, I'm just going to refresh the page. So when you go to the installation, we have our repositories. Since I'm on Debian, I'm just going to do the standard audio. Okay, good. So I'm just going to do the standard installation. So I'm just going to copy this command here and head back to my terminal, and hopefully they don't flip out. And oh yeah, it's flipping out. I can see it. So right, stop this from flipping out. I'll just do this. Is that better? No, it's not better. I can see it flipping out on the left hand side. Let's do this. More actions. No. Is that better? No, still flipping out. Live debugging. Right. I don't want to make it unreadable for you guys. So what I'm going to do is I'm going to do this. Okay. How is that? It's still flipping out. I can see it. It's really annoying me. But doesn't matter. Let's continue on. Okay, so we've installed the package cloud repositories. So now we can just do apt install CrowdSec. If I can spell CrowdSec correctly. And what this will do now is it will download CrowdSec and install the binary and run it as a service. So let's just wait for that to go. So the key points I just want to show out here is that when we're installing CrowdSec, we have a auto acquisition mode, as we call it. But basically, it will scan the system for services that are running and then automatically configure CrowdSec to monitor them. So you can see here, I've already got Nginx installed. So it's automatically configured Nginx. Well, not configured Nginx. It's automatically configured itself to monitor Nginx deployment that I've got here. In simple terms, what that does is inside the acquisition file, you'll now have this at the very top. So it knows that it needs to go and look for the Nginx log files. Okay. So once we've got CrowdSec installed, that's the monitoring part done. So any attacks that go and hit my SSH or my Nginx now will be covered. However, I still want to be able to do some remediation off the back of it. So I'm going to do is I'm going to install CrowdSec. What I'm going to do is I'm just going to close this, and then hopefully, no, it still doesn't like it. Still flipping out. It's so annoying. I don't understand why it flashes. Even if it's full screen, it still flips out. Right, 2 seconds. Whilst I'll get back to... Okay. So when we have installed CrowdSec, we can then install CrowdSec, Firewall, Bouncer, and then IP tables. I'll probably spelled something wrong again. Install CrowdSec, Firewall, Bouncer. Not just tables, IP tables. So the IP tables component, if you're not familiar with what IP tables is a Linux firewall, and on most distributions, it will either come with NF tables, which is the newer variant, or IP tables, which is older, but it still works. So I'm going to stick with IP tables because that's what I know. So in short, what does this remediation do? So if I run IP tables with a capital L to list all my chains, at the very top, you can see there's a drop command that says drop anything that matches the CrowdSec blacklist. That's the IP set that we use on the default installation. However, that's not what we're going to do in this demonstration, because we want to do something more advanced, more sneaky, for when the attacker attacks us. We don't want them to know that they've been pushed to a sinkhole where they're just getting fake data or from the application. So the first thing that I'm going to do is I'm going to stop the service, so the CrowdSec Firewall Bouncer.service. The reason is because I want it to bring itself down and remove any of the chains and any of the configuration that's already spun up when it's in managed mode. So we can see here that it didn't remove it, so I'm just going to run IP tables delete input 1, and that will then remove that command. And then if I also do IP set list, we also need to do IP set destroy, I believe, and then CrowdSec blacklist. Voila. Okay. So now it's got I've got no IP set, and I've got no automatic remediation that's been set up from the firewall. And the reason is within the IP tables bouncer config, you can set it into IP set mode, so it just looks after the IP set. It doesn't create the rules for you. So I will do that now. So to use IP set mode, you must create the change yourself. So the way that we do that is, if I paste it correctly, is we need to create the IP set list. All of this is at the bottom of the documentation. I don't want to show you documentation right now because it will make my screen flip out again. But these IP set create commands are at the bottom. So once we've created them, if I do IP set list, you'll see that the IP sets that I've created are now here. And obviously there's no entities inside of them. We are then going to use my favorite text editor, Vim, to go and edit the bouncer configuration. Video is blurry. I can see that my CPU is taking a hit. It's on 50%. It might be just your end though. Yeah. Vim, CrowdSec, and then we head into the bouncers directory, and then there's the firewall configuration. Now this mode that's at the top is what will need to be changed if you want to put it into IP set only mode. So instead of IP tables, where it will create the IP set, create the chains, do all that stuff for you, we will just change it into mode IP set. That means we only want it to look after the IP set, nothing more. Once that's done, we'll close the configuration, and then we'll do systemctl start CrowdSec dash firewall. Let me know if you can't see it because it's too far at the bottom. But yeah, systemctl start CrowdSec firewall bouncer. Okay, so once we start the bouncer, if we look at the IP set list, we'll now see that there's no entries in there. But if I do CSCLI decisions list -a, yeah, you see that I have no decisions anyways. That's the reason why there is no list in there. So what I'm going to do is I'm just going to restart CrowdSec, just so I can get the latest pull of the community list. Don't want to give you any ASMR on me drinking. Okay, so after that is done, if we now do IP set list again, now you'll now see that I've got IP addresses in the list. So it shows that that configuration that I've just done to the firewall bouncer is working correctly. Okay, so if I go to my attacking machine, and if I grab my IP address, so warning, if you attack this box, this is obviously going to report your IP address because it's being actively monitored by CrowdSec. So if you don't want to be reported, don't attack this box whilst I'm live streaming. Okay. So if I kill this IP address, you'll see that I get the Nginx page. That is what I expect to happen. Because obviously I'm going on to port 80, I'm hitting the HTTP server, and I'm getting the Nginx page. So what we now need to set up now is the sinkhole application. Yeah, I have a so beauty. I have what's it called? Noise cancelling on my mic, and then sometimes it might dip too much if I'm talking for a long period of time. I can turn off the noise cancelling, but you're gonna hear my laptop fans. We'll just see how it goes for now, but keep telling me if it does. Yeah, because I can turn it off, but like you'll just hear my fans of my laptop. But I'll continue for the minute, but then if it gets worse, just let me know. So we're going to have to set up a sinkhole application. So if you're not acquainted with Blue Team, so they've created an application called Spider Trap. So what spider trap is, it was created some time ago, but all it basically does, yeah, that's fine. I'll show you if I switch my properties. I can this, and then this is the normal mic with no noise cancelling. You should be able to hear a lot of fans, and you probably have to turn down the stream a lot better. Okay, I'll keep it like this, but I don't like the fans in the background. It normally annoys me. Okay, let's keep it like this. Yeah, there's a lot of fans because my laptop's like trying to obviously do the encoding for the stream. But I'll turn myself down a little bit so I don't like sound like I'm screaming in your ear holes. But this spider trap application, I'm planning to rewrite this in Golang at some point. But basically, all it basically is here's the title line. It just generates a page with random links, but it generates it for every single web page. So every time that they go to a page, if it's a crawler, then it will just keep generating more and more links. So the crawler thinks, oh, new link, and it will just keep getting stuck. It's like if you've ever used like SSH targeting, so like showing you a banner, it will just keep getting stuck in this massive loop. So you can use this as your application to do. So I'm just going to grab this link for spider trap. Yep. And then we're going to cd into my op directory, and I'm just going to git clone this. And I don't have git installed. Nice. Let me just install it. And I'm just going to remove the thing behind so it doesn't look like it's spamming out the thing. Okay. So I'm just going to git clone this. Okay. And okay. So now we have spider trap. And then do I have Python 3 installed? I do have Python 3 installed. Let me just see if I can spin it up. Okay, and I'm just going to send another kill request from here and send it to 8,000. Nope. Okay, yeah, and I know the reason why. Okay, that's fine. Give me 1 second. Okay, so I'm just going to check my let's see, pass to BD. I need to okay, yeah, so I do have a dub data. So I'm just gonna do some basic configuration for this application. So I'm just gonna change the owner of this folder to be the dub data user, because I want to set up a service for this application, but I don't want obviously the application to be running as a root. So now if I do ls tac la, we should now see that dub data is the owner of this spider trap application. Next, we're going to have to set up a service file. So if I do here is what I prepared earlier. So if we go to, just looking at my notes, if we go to lib systemd and then system, we can create a systemd unit for the spider trap application, so we can treat it as a proper application rather than just like an application that would just run once. So I'm just going to vim a spider trap.service, and I'm just going to paste in like my actual notes apparently. So I'm just going to change a couple of some of this stuff just to be like, okay, so the description is spider trap. The user is going to be dub-data because we want it to be obviously running as the user. I don't want to work in directory, that's fine. It's a simple application. And then we will then tell it that it needs to go to opt/spider trap, and then spider trap.py. Okay. And that should be it. Let me just double check the Python 3. User bin Python 3. User bin Python 3. Opt spider trap, spider trap.py. Let's just double check that. So spider trap, opt spider trap. Okay, so then if I do system ctl daemon -reload, and then if we look here now, okay, yep, so there you go. So now I've set up a service file for this application, and now I should, hopefully, if the configuration doesn't explode, I should be able to start the service. It's active and running. And then if I look at my ports that have been in use, LNTP, we should now have an application that is running on port 8000, and that is the spider trap configuration. I hope that was somewhat easy to follow. I know I just did it really, really fast, and I know that my thing keeps triggering really loud. But basically, you can git clone the spider trap. We can then create a service called spider trap. We then tell it that it runs as the dub data user, and it will execute the Python 3 spider trap.py service. And then that is the configuration. We can ensure that it is working if I kill localhost 8000. You'll now see what the application does is that it returns a bunch of A tags that has a random URL in it. But that's the premise of the sinkhole application. However, we don't want it to be obvious to the attacker that they're being diverted to a sinkhole. So what we're going to do is some firewall, like network address trans pre-routing table. So I am going to do another, here's what I prepared earlier. So if it lets me copy it, apparently. Okay, so I'm going to break down this command. So we're doing the iptables command, and we're picking the network address translation table, and we're appending it to the pre-routing table. And we're basically saying that anything that has the destination of port 80 and it matches the CrowdSec blacklist. So you remember when we did the configuration for the firewall bouncer, if it's coming from there, yes, it will be available. It won't be available straight away. I'm going to do a little bit of editing and then I'll re-upload it, just so you can follow it at your own pace, because I know I've only got 1 hour to do this, so it's like running quickly as fast as possible. But basically, we're going to match on the CrowdSec blacklist, and if that happens, we are then going to redirect the packet to port 8000, which is where the trap is listening. So if we append that, and then if we do iptables tnat with a capital L, we can then see that we have this redirect port. However, the most common thing that attackers will do when they're looking at your application is they're going to run something like mmap, and they're going to be able to see the application listening on port 8000. So if I do, which is not what you want. You obviously don't want them to be able to go directly to the sinkhole and be like, okay, well, if I'm getting all this stuff, it's pretty obvious that it's either a honeypot or some sort of dodgy application. So instead, what we can do is we need to allow the forwarded packet that's coming from the DNAT chain to be allowed through only if the packet is come from the NAT table. If it hasn't, then it will be blocked. And the way that you do that is this command. So I'm going to change the D port because I was playing around last night and I was playing around with the delete port. But basically what this command will do is it will insert on the input chain, which is the standard chain for most applications, for IP tables when it's an input coming in. We're going to match on TCP, and if the destination port is 8000. However, we're going to match if the connection track comes from the DNAT chain. If it does, then we will accept it. If it doesn't, if someone's going directly to the port, then they will be dropped. Well, depends on the configuration, but my chains are set to drop if nothing matches. So if I insert this and I do IP tables -l now, you'll now see I have accept if it's established or related, except if it's destination port 8000 with that constraint of coming from the DNAT table. And then here's all my other like box standard, allow HTTP, allow HTTPS, SSH, that kind of stuff. This one in the middle might look weird, but it's just because it's matching on loopback, so it's not matching everything. Okay, so that should be it. That should be all the configuration that needs to be done to be able to detect an attacker, because we set up CrowdSec at the start. It's now monitoring Nginx. So if somebody attacks the Nginx application, it will then trigger a rule that the firewall can go off and then forward it to the port 8000, which is where our dodgy application is living, where it's doing it. So we should always test everything that we set up. So what I'm going to do here is I'm just going to run a CVE scan. So I know this kind of looks like magic, that there's a CVE scan, like binary, but it's not. It's just a alias for Nikto. So CVE scan is just literally Nikto that's running on the host that I pass in. So CVE scan and then HTTP, and then we're going to run on it on 104.248.86.155. Okay, so now that's running. It's doing a bunch of stuff. So now if I do CSELI decisions list, you'll now see that this IP address is blocked from the machine point of view. However, it's not blocked in the same way. So if I do IP tables and then L with a V, you'll now see that if I zoom out a little bit, you'll see that this chain here is receiving the packets. So our redirection rule is working. It might not look obvious. Well, it looks obvious now, but you can see now that they're just getting bombarded full of 200 requests saying, hey, I found this. Hey, I found this. Like, they're now getting given totally dud information. We can make this even worse for the attackers if they're running something like wget or like some sort of crawling software like Firewall. So I'll show you Firewall because I was playing with this last night. So if I do Firewall and we do --URL, and then what I'm actually going to do is just going to do this, and then Firewall --URL. So if you don't know what Ferrous Buster, I can't even get my words out. So if you don't know what Ferrous Buster is, it's basically a automatic recursive crawler used in penetration testings to do a bunch of crawling of the website and just get a bunch of URLs that you can then feed into something like GoBuster, which then does a targeted word list attack on each one of the directories. However, if you think of it from the crawler point of view, when it hits all these URL pages, each one of the links is a unique link. So it's just going to recursively keep going deeper and deeper. So if I hit enter here, there'll be a lot of stuff that shows up, but I'll break it down. So you can see that it's hit a bunch of links, and it's like, oh, I found this. Oh, I found this. And look, you can see here that it keeps popping up with these random names. Obviously, to us, this is like really obvious that it's just something's happening. There's a bunch of things like dud stuff that's happening, but to the attacker, they're just attacking HTTP, and they don't know that they're actually being redirected to a different port that they don't see because it's blocked for them on that regard. So what I'll do is I'll cancel this attack now. Okay, give me 1 second, I'm just going to take a quick drink. Right, so that is pretty much setting up the sinkhole and setting up the redirection or the firewall configuration. Does anyone have some questions at all? But keep in mind here as well that this is only one application, so redirecting HTTP to another HTTP server, but you can do anything you like. So if I call on one of my favorite YouTubers, IPSEC, he has a video where he's done the same thing, but he's basically got a SSH honeypot. So if this person then tries to get into port 22 and they've already been known to them, then it automatically redirects to a honeypot on the same port. So you can do anything that you like. This is just a example that shows you HTTP server redirecting into a sinkhole application where it will just waste the attacker's resources because they can just keep crawling forever. Is there anything else that anyone would like to see? Because I know that I've gone really fast and we still got 25 minutes left. I can also show you as well. So if you go to curl, where's the curl? So if I did try to go to port 8000, you can see that I don't get access. So this is to show you that if somebody were to so if this works fine, let's have a look. So if I were to go mmap and then 104 248, you know what, I could just go here. And then if I do port 8000, you'll see that it says filtered. So they obviously know that it's being actively dropped and so then if I did something like, I think this is the way you do it, 18443. So you can see that they can see that it says filtered. So there is something there, but port 8000, port 8080, it's common that these ports will be filtered anyways. So it's not going to give them a direct knowledge that this is like a honeypot kind of deal. And then like, let's whack 22 on there, and voila. So it looks like a standard box that you see out on the internet. Okay, what I'm gonna do is, since I've done it really fast, I'm gonna wrap it up. Please give us some feedback on the stream. This is the first time that we have actually done like a YouTube stream. Normally we were using a different platform called Livestorm, but people didn't really want to sign up for it, and we find it better that we just interact on YouTube instead. I don't have a outro screen like I did have an intro screen, so I'll see you guys in the next stream, which is on just before Christmas. So I'll link that in the chat now. So the next one will be on setting up a SSH tar pit. So if you like this video and you liked setting up a sinkhole application, you'll love setting up a SSH tar pit and the benefits that it can bring. Obviously that you waste attackers' time, as well as, let me just grab the link. So yeah, so we set up an SSH tar pit. We trap everybody that gets into it, but then we also, as well, protect our real SSH port, because all the bots and all the people that just attack port 22 will just be trapped, and then at least our real SSH port will be unknown to the attacker, unless they obviously do an MMAS scam. Okay, I'm going to wrap this up now. Thanks for coming, everyone.